The broadcast is now starting. All attendees are in listen-only mode.
Well, welcome everyone to today's Onset webinar. My name is Paul Gannett and I will be presenting this webinar. We're going to focus on how water quality data loggers can be used to better manage and restore native fish habitats. As part of this, though, we'll also be learning how some tips on deploying water quality data loggers in general. So even if you're not specifically involved in managing native fish habitat, there'll probably be some useful information as part of this as well. So this is just a prompt if for folks that aren't able to hear me to check their audio settings. If you're hearing me talk right now, that means that you're good to go. As we're waiting for people to get all logged in, I'm going to give you a couple of notes about the webinar. I am recording this webinar and it will be made available to attendees afterwards. The webinar will run for about 45 minutes, including time for questions. If we don't have time to get to all the questions, we will follow up with you afterwards. Or if it's a very specific question unique to your application, we may save it for individual follow-up as well. Feel free to submit your questions at any time, and you can enter them into your control panel. There's that box that's labeled questions. Just enter those in, and I should see them. So just a quick introduction to Onset for those of you who aren't familiar with Onset. We've been making and designing data loggers since 1981. Our HOBO data loggers are used around the world for environmental monitoring applications as well as for building management applications. We do have a global network of distributors. So, and I've noticed from the attendee list, those that you have signed up for this webinar, we have attendees from all around the world. So welcome everyone. Just a little bit about me, so you know who's talking on this end. I've been with Onset now for 21 years, and I've been involved in helping to develop all the products that we're talking about here today, and working extensively with users in many of the organizations, leading water and environmental organizations around this country, and as well as some international organizations. Of course, the USGS, managing water resources, EPA, Fish and Game departments, DEPs, NEARS, a lot of different organizations, a lot of universities and environmental consulting companies as well. I live and work here on Cape Cod, where the ponds, streams, estuaries, and the oceans are central to our economy and recreation. That's a picture of my son there showing off his big fish that he caught. We love the environment we live in, and we want to do all we can to help protect it. In particular, today, I'm going to be talking about streams where they have native sea-run brook trout. This is a species that has been on the decline. There's not many places left where they still are able to sustain a native population. We're fortunate here on the Cape that we do have some native populations. You can see the dark blue lines indicating some of the streams and brooks that are sustaining brook trout populations around the Cape. Unfortunately, though, there's a lot of factors that are impacting them. One of them is agriculture. Cranberry bogs are the big agricultural product around here, and we love our cranberry growers, but also the bogs have a potential to impact our brook trout. We also have had a fair amount of development over the years, and that, of course, can impact the streams. And as we all know, the climate change is a factor Oh, I just got a notice here that there's a little bit of delay between when the screens show and when I'm talking. So hopefully I'll give a little bit of time for the screens to show before I start commenting on them. So thanks for that note. But yeah, climate change, of course, is affecting the environment in many ways. In particular, what's at stake for the sea-run brook trout? Here's some headlines from 2015. Sea-run brook trout vanishing from Cape waterways. And then in October, there was a survey conducted where they failed to turn up a single brook trout in the Santua River. Here they're using electrofishing to see what they find. So that's not good when you're not seeing fish at all in the streams. So here's one of the researchers, Steve Hurley. He's with the Massachusetts Division of Fisheries and Wildlife. And he and many other organizations are working together to protect the native sea-run brook trout. And I worked especially closely with Steve to learn about their work. But you can see logos from other organizations that he's been working with. Some provide funding, some provide expertise. And everybody works together. You'll find that in a lot of restoration projects that many organizations work together to make things happen. The Sea-Run Brook Trout Coalition is helping to coordinate these several different groups. So one of the keys to them doing their work is to be armed with data. If you don't have information on what's happening, it's hard to make decisions and hard to make improvements that help to make for a better environment for the brook trout. So data was a key part, and that's where we Onset Computer and our HOBO data loggers can kind of help, and we want to be part of the solution. So to start out, I just want to get a sense for where all of you are at. So I've got a little question here, a little questionnaire. So I'm going to launch this, and basically the question is, how are you using or planning to use water quality data loggers? And here's your choices, and hopefully you're seeing the screen. Yep, okay, good. I can see the responses are coming in, and interesting. I just switched to a different screen here. While the polls are coming in, I'm going to get back to the screen that I wanted to be on. There we go. And okay, let me close this because I think most people had a chance to respond. And yeah, okay, I was afraid of this. I intended to allow you to choose multiple options here, but it turns out that the way the GoToWebinar was set up, you're only able to choose one. So hopefully you've chosen the one that's most relevant for your application. So sorry for that bit of confusion, but here's the results. Hopefully those are going to show up on your screen in a minute. I'm going to jump ahead as I'm not sure. For some reason, that's not showing up on my screen, but hopefully you're seeing it. But 30% of the respondents are doing environmental research, so that's the biggest area, followed by 24% doing aquatic biology, and then tied for third is stream restoration and environmental compliance applications at 20%. So pretty good distribution actually across those application areas, and 7% chose other. So yeah, if you chose other, you can enter that into the question area, and I'll see that. And that just helps me get a sense for other areas that you're using the loggers. So all right, so let me close out of that, and we'll go back to the presentation. Hopefully you're seeing the slides now. If you're not, let me know. You should see a slide that says, what did Steve learn? And he used data loggers to look at things several different ways. And one of the things that they did was looked at temperature versus fish activity. They have antennas that were looking for the tags that were implanted on the fish. And so when the fish were migrating through the streams, you could see them, see that they're passing by these antennas. So the antenna that we're interested in for this study is the green line here, which shows the activity of fish going by the antenna. And if you look closely, it's a little hard to see, so I've got some arrows here to point things out, is when there's a temperature drop, that triggers the fish moving upstream. They're looking. They don't want to go up upstream if the water's too warm. So those temperature drops can trigger the fish activity. One of the things you'll also notice here is the brook trout. They do their spawning in the fall, so that's why you see the activity of them moving upstream in the October-November timeframe. Another thing that they found that triggers the fish movement is the tides, as you'd expect. This is a tidal stream, the Santuit Brook, and several of the other streams. And you see this black line here, that's the water depth, and so you can see the two tides over the course of a day. And the red triangles are when the tagged fish would move by the tracking device. So you can see when the tide came in, that triggered a lot of the fish to migrate upstream. They also found a correlation with the sunrise and sunset as well. They tended to move more during the daylight hours. Another thing they found is the average temperature of the streams had a significant factor on whether they could support brook trout or not. Here you see a graph showing one stream in red, the Weir River, and you can see the temperatures there were too hot for the brook trout, so no sustained brook trout population in that stream, whereas the blue line is for the Gannett River, and that fortunately is able to support a healthy trout population. So the average temperature is very critical. What else did they learn? There's several factors that affect the stream temperatures: air temperature, solar radiation. You can see the daily fluctuations of air temperature, and you can see the corresponding fluctuations in water temperature. Those are the three lower lines are water temperature at different points in the stream. And as a matter of fact, they correspond to upstream to downstream. So the upper line is the orangish line is the most upstream, and the blue line is the most downstream. And one of the things that you see is that the stream temperature goes down as the water flows downstream. And the reason for that is that the stream picks up groundwater, which is actually cooler than the water that was released at the top from the ponds. So the groundwater actually helps reduce the water temperature, which helps. Tides can also affect the water temperature. Now you don't see that here because these points are a little further upstream. So what else did they learn? Well, sorry, this graph's a little bit busy, but focus in on the red line. That's the Santuit River. That's the one where they saw the collapse of the brook trout population. And you can see in 2013 that they had an especially high average temperature through that year. It was up above 68 degrees, almost 70 degrees. And it was after that that they found that there was a collapse in the brook trout population. So yeah, that was very bad for the trout population. And you can see the Coonamessett River, the purple line at the top. That has not been able to sustain a brook trout population at all. So again, temperature is a big factor in stream health. So what did they try to do about keeping those water temperatures down? Well, one of the things that they found that they could do is wait until the fall to open up the fish ladders. Now, they have to open up the fish ladders because another species of fish that lives in these ponds and streams is herring, and the herring actually go up in the spring to spawn, and they go up into the ponds, and they'll spend much of the summer in the ponds, but they need to get out to go back out to the ocean for the winter, and so they need to open up the gates for them to come out. But that also releases the warm pond water, so you want to wait until the ponds have cooled enough so that you can safely release that water into the streams. Another thing that they found is with the cranberry bogs. Cranberry bogs potentially can create a lot of warm water because they're very shallow, the sun's shining down on them, especially if they're dark on the bottom, really warms up the water. So one of the things they want to do is avoid cranberry bogs having a large area that's shallow that could cause solar heating. The other thing that they do is they're now designing the bogs so that the drainage streams that go around the bogs are around the outside of the bogs. And that way they pick up more groundwater. As I mentioned before, the groundwater is cooler than the pond and the bog water. And by having these channels go around the outside, they pick up more of that groundwater. So that helps to keep them cooler. Another problem they found is that the clearing of the woody structure, clearing of stumps and trees along the streams, actually resulted in a higher mortality from birds and other predators eating the brook trout. So the solution to that was to actually add back in woody structure, throwing in some stumps and cutting down some trees so that they fall into the stream, and that helps provide cover for the fish. And so the good news is that due to these restoration efforts, that the sea-run brook trout are actually being reintroduced into the Santuit River, and they are surviving. So they seem to have been able to restore that to a state where they can sustain the fish population. So that's really good news. We're very excited about that. Some other restoration methods that are used around Cape Cod are covered here. These are in different locations. This is Stony Brook, which is a important herring run for the herring to go up and spawn. And in this case, the spawning runs were being discouraged by a culvert that was too small under one of the roads in the area. So the normal tidal flows were not sustained. So like the ecosystem on the other side of the road was turning to more of a freshwater ecosystem than a saltwater ecosystem like it should have been. And the herring were not going through the culvert. And for this, they did some studies, with temperature loggers, water level loggers, and salinity loggers, as well as some with dissolved oxygen loggers to monitor what was happening. And so they saw these effects, the reduced tidal flows into those areas. And so that was kind of the before study. Then, let me skipped ahead here. Then what they did is they put in the culvert, which was much bigger. Then they monitored those same parameters and basically confirmed that the culvert did what it was they were hoping it would do, which is to restore the normal tidal flows, and it did. The flows on the other side of the culvert now followed their more natural pattern. They found the herring migrated up more. And it was successful, and they're able to use that to justify other research projects around the Cape. A lot of restoration efforts going on. Another restoration method is removing dams. This is Plymouth Town Brook. You may remember hearing about the Pilgrims using fish to fertilize their crops. They were taught this by the Indians. Well, this is one of the brooks that they got the herring from, and but unfortunately, over time, there was dams built up along this brook, and that basically stopped the normal spawning runs of the herring. But now they've been removing the dams, and it's been restoring the normal fish migrations, and again, it seems to be working. So in this case, they were monitoring temperature and water levels as well as fish counts. So here's some other tips to keep in mind when you're considering data loggers for monitoring these kind of projects and understanding what's going on. One thing is water level can definitely provide additional insights. Here, the green line is the water level in the stream, and you can see after a rain event, as shown by that big spike in the water level, that that changed the temperature regime a little bit. So it's good to know when those rain events happen so that you can factor that into your observations and conclusions. Dissolved oxygen can provide another insight into what's going on. If the dissolved oxygen levels get too low due to algae or stagnant waters, those can that would obviously be a problem for the brook trout. They need to have a certain level of oxygen to survive. And by doing continuous logging of the dissolved oxygen levels, you can see things like algal bloom events. Here, that red box shows, this is actually out in Buzzards Bay, so this isn't actually a stream, but you can see the same effect in streams, is when you get an algal bloom event, there's a big increase in the oxygen levels, but then a big crash in the oxygen levels. So that's a sign that you have an algal bloom. Other useful parameters are air temperature. You may remember the earlier graph I showed where you could see a definite correlation between air temperatures and the stream temperatures. So usually that's important to monitor as well. And rainfall. You can deploy standalone rainfall loggers, such as this one, which is one of ours, to see what rainfall fell in that area, and so you can correlate that with stream level rises and temperatures and other factors in the stream. So one of the things you'll see with rainfall is it can vary quite a bit over an area, so it really is best to monitor the rainfall right in the area that you're studying if you can. So here's our friend Steve again. He shared several different deployment tips, which I'm going to share with you today. First one is deploy data loggers before and after a restoration project so you can measure and learn from the results. Deploy water level loggers and temperature loggers at the same location as the fish counters so you can directly look at the correlation. Make sure that your data loggers are deployed in locations that will have water even during low flow conditions. That's sometimes a challenge, I know, but streams can get quite a bit shallower during the warm summer months when you're not getting much rain. So look for a pool that's going to still have water in it during low flow conditions. Another point, this is specific more to our loggers, which have optical communications. We provide them with protective caps. Use those protective caps to keep the communication windows clean of any fouling. And for critical sites, use your newest loggers or ones that you're sure have enough battery power to get you through the season. So that's often an issue. You certainly you want to check the battery levels before deployment just to make sure that they're reasonably good. And another point is when you launch the loggers or start the loggers, launch them all with the same start time. This makes it a lot easier to analyze the data afterwards. That way all the readings are lined up with each other in time. So we asked or offered that you could send some questions in advance, and one of the common questions was just asking about our different data logger options. So please forgive me. I'm going to talk a little bit about our HOBO data loggers. And these are examples of the sort of products you can use to monitor water quality. And of course, you can use other vendors' products as well. But this gives you a sense for what we offer. Um, we're known for our self-contained data loggers, which are really easy to deploy. They've got the memory, the measurement sensors, the battery, everything built into the same logger. We have loggers with up to 0.2 degrees Celsius accuracy. We have some with light sensor options. I'll talk a little bit more about ways that might be handy later on. We also have the battery life of the loggers can vary between 1 and 6 years. For the loggers like the pendant in the upper right, that has a 1-year battery life, but it's a user replaceable battery. So you can easily replace the battery with a coin cell battery. We have 2 series of temperature loggers now. We have the optical USB series, such as is shown the 3 loggers in the upper right, the Tidbit and the Pendant and the HOBO Water Temp Pros. Those start at $42 in US dollars. And then more recently, we just late in 2017, we introduced the MX 2200 series loggers, which feature wireless data offload with mobile devices such as an iPhone or an iPad or an Android, using the Bluetooth that's built into those devices. Those are pretty reasonably priced as well, starting at $54 US dollars. And those also, well, yeah, both the Optic series as well as the MX 2200 series have models with light sensors. If you're measuring light, I would recommend the newer MX 2200 series for the light measurements, because the light sensor in that is considerably more accurate than what was in the original Optic pendant. So talking next about water level loggers, we have several different options in this area. Some of the loggers, the ones with the narrower range, the narrower measurement range, have 0.1 foot accuracy typically, and that does require barometric compensation to get that accuracy to compensate for changes in barometric pressure. The basic loggers are the U20 and the U20L series. These are non-vented, self-contained loggers. They record absolute water pressure, and they require a separate data file with the barometric pressure to use to compensate for the barometric pressure changes. That could be another one of these water level loggers deployed in the air to record the barometric pressure. Our software will do the magic of doing the barometric compensation using those data files. They have 5-year battery life, and for the U20L series, the pricing's under $300, so very affordable. And more recently, we've come out with the MX 2001 series, and these also have the Bluetooth technology, which means you can offload them and configure them with a mobile device such as an iPhone, just like the MX 2200 series I just mentioned. And one of the nice things about these loggers is they have a cable that connects the sensor in the water to the transmitter unit at the top, and that transmitter unit at the top does the Bluetooth communications, and it also has a barometric pressure sensor built into it, so that you can directly read out the water level data. It also has user replaceable batteries up there, so you can replace those as need be. And we did have a question here about, do we offer a logger that integrates water level, conductivity, and temperature all into the same logger? And at this time, we do not, but that is something that we are looking at and hope to offer at some point in the future, but it's not available from us at this time. We do have, well, here on this next slide, we do have separate conductivity and salinity loggers that people quite often do use in conjunction with our water level loggers. And it's still, even though it's two different loggers, it provides a fairly affordable solution. The conductivity and salinity loggers start at $750 US. In fresh water, they can deliver 3% accuracy. We actually sell two different models, one that's optimized for fresh water, which is the U24-001, and then we have a saltwater version, which is the 002, which goes up to conductivities of 55,000 microsiemens per centimeter. Our software will do the conversion to salinity. We also have the U26 dissolved oxygen loggers. They use an optical DO sensor technology, provides an accuracy of 0.2 milligrams per liter for the lower level measurements where it's most critical. The oxygen levels are most critical, and that sells for $1,250 US. Both of these loggers have a 3-year battery life, and they're also compatible with the waterproof data shuttle. We also get, I think there was a question on this, is do we have options for remote monitoring of water quality? The way somebody would do that now is to use our RX3000 remote monitoring system. This provides internet access from desktop or mobile devices, anything that can be running a web browser. We have cellular and Wi-Fi and Ethernet communication options for the RX3000 to get the data onto the internet. It's got a double weatherproof enclosure for reliability in harsh environments. We sell a range of plug-and-play sensors for this, but it also has an analog input module for connecting third-party sensors, such as water level sensors and water quality sensors. So if you have let's say a DO sensor or a water level sensor that has a 4 to 20 milliamp output, that can be pretty easily connected into the RX3000 remote monitoring system, and we have some documentation for doing those connections. And then you can be remotely monitoring those important parameters, as well as getting alarm notifications by text messages or email when critical conditions are met. So that's an option to keep in mind. It's a little bit more expensive than our standalone loggers, but if you need to have instant access to your data at any time, or if you need alarm notifications, it's a good option to keep in mind. So back to some of Steve's deployment tips. One of the issues that's common is vandalism. Could just be curious people that are taking a hike through the area. They see this logger, they wonder what it is, and they pull it up, get some bad readings. They may not put it back where it was. So to help avoid this kind of vandalism, quite often, and probably more often than not, he will deploy the loggers on the bottom of the stream where they're less likely to be seen. So there's various ways you can monitor or mount them on the bottom of the stream. And here's a couple of possibilities. One is to create like a cement block with mounting bars on it that you can attach the PVC pipe to, which you can put loggers inside. Or another choice is a concrete block. They're pretty readily available. Sometimes these are a little heavy to take out into the site, but maybe sometimes people will use a lighter concrete block, take it out to the site, and then bury it in local rocks as another, to kind of stabilize it in position. And one of the challenges, though, is when you're mounting these on the bottom is how do you find them again? So you want to make sure to use some sort of marker that's on the shore where you can find it. Look for landmarks, take pictures. One common technique I see is actually having somebody stand on the bank of the stream or in the stream and point to where the logger is deployed, so that you can kind of get a visual indication of where to look for the logger when you go back to retrieve the data. GPS is another important way of tagging where the loggers are. So here's some other deployment options. So there's on the upper right, there's a concrete block being used with a PVC pipe, a metal pipe attached to a rock. And then on the left is a picture of a stilling well next to a staff gauge. And one of the advantages of using a stilling well to deploy your loggers is that you can get access to the loggers from the shore. You can pull them up and offload the data and redeploy them from the top of the stilling well. Now, the downside, of course, though, is sometimes that stilling well is visible. If you're deploying loggers with direct readout cables like the MX 2001s that I showed you, you would pretty much most cases you'd need to put them in a stilling well like this so that the top unit with the Bluetooth communications is above the surface so that it can transmit wirelessly for readout. Let's see. I'm just going to check the questions real quickly here. Yeah, okay. Yeah, okay, a couple good questions. Let me touch on a couple of these. The first question is the RX3000 suitable for aquaculture or fish farming live reporting data? And yeah, we do have some users that are using the RX3000s and for monitoring. You've got to have the right sensors, of course, but because it's able to report the data in near real time, you can get data uploads to the internet as fast as every 10 minutes with the cellular option. You can even get uploads as fast as every minute. No, I'm sorry, it's still every 10 minutes with the Wi-Fi option. So no, 10 minutes is the fastest upload rate. And so you can get some pretty real-time data with the RX3000. Of course, you got to have the right sensors connected in. And no, but the RX3000 is a good solution for monitoring aquaculture and fish farming sites. Let's see, what else do I see here? Oh, there's a question about the concrete block. Does that interfere with water quality measurements, such as conductivity measure by raising ions? Yeah, that's a good question. Yeah, if it was a rock or a concrete block that was releasing a lot of lime or something like that into the water, I guess I could see that. But you see that such a slow release. I've not heard of the conductivity measurements being affected by the concrete block. So I think you're probably okay there. I mean, that's a good thing to be aware of, but I think that their release is so slow, especially if there's a good flow of water, that it's not going to be a problem. One thing you do have to be careful with the conductivity measurements is if you put it in a metal stilling well, that can affect your conductivity measurements, and it really should be mounted in like a PVC stilling well, so that it, because the PVC won't have much of an impact at all on your conductivity measurements. Yeah, same thing. We have a question about a fence post. Same thing. Metal could be a problem for conductivity measurements. So you want to, if you're mounting it to a metal post, which is pretty common, you probably want to put it in a PVC pipe and mount the conductivity logger so that the sensor is facing away from the metal post. That'll minimize the effects of the metal on the conductivity measurements. Yeah, there's some questions about sensor cleaning. I'm going to address those in a minute. Yeah, lots of good questions coming in. I may not get to all of them, but that's okay. Like I said, we can follow up. So, no, just a point. Some people will deploy water level loggers in weirs or flumes to monitor flow rates. You want to use an integrated stilling well in those if possible. And this is a question that's come up a few times: is calibration of HOBO data loggers? And the answer is it really depends on the logger. The So for temperature loggers, let me define the types of calibration first. Lab calibration, there's only one of our loggers that supports lab calibration. That's our dissolved oxygen logger. And what that is in the lab, before you deploy them, you put it in different calibration environments, and it adjusts the calibration factors in the logger for those environments. So that's important for dissolved oxygen measurements. So we provide lab calibration. Another option is field calibration, and that's where you take a measurement in the field next to your logger, and that can be used to adjust your readings. So we offer field calibration options for our conductivity loggers, our dissolved oxygen loggers, as well as our water level loggers. In the case of a water level logger, that's your reference water level reading is basically your calibration point. All your readings will be adjusted to match that reference water level reading. Then a comparison check. Well, that's commonly used with our temperature loggers. So before a deployment, quite often users will put a bunch of their temperature loggers that are going to be deployed into a stirred calibration bath that's all at the same temperature, and then read out the loggers afterwards and make sure that they were all reading within like 0.2 degrees C of each other. And if there's some outliers, don't use those outlying data loggers for the deployment. It's a good, simple way to check the calibration is still accurate. The temperature loggers do remain stable for many years, but it's always good to check them before a deployment. Fouling is a challenge in these environments. So here's just some things to keep in mind there. I could do a whole course just in dealing with fouling, but here's some basics. One approach is to deploy in a PVC pipe with holes to reduce the light reaching the logger. You'll get the fouling will kind of build up on the outside of the PVC pipe, but the logger inside it will be cleaner as a result. Another approach is to use copper in some form. We sell an anti-fouling cap for the HOBO DO logger. For the other loggers, we don't have anti-fouling accessories, but a lot of people will put copper tape near them or screening around the outside of a PVC pipe as ways of reducing the biofouling because of the natural effect of the copper. It reduces the biofouling on the sensors. And basically, depending on how much fouling you have in your environment, you'll need to go out and clean the sensors. Now, temperature loggers, it's not a big deal. If they get a little fouling, that's not going to really affect the accuracy. But for the conductivity loggers and the DO loggers, you need to brush off that fouling to get accurate measurements. Here you see the sensor for the conductivity and salinity loggers, that little square, that silver square in the middle of the circular area. That needs to be brushed off with like a toothbrush. It's a pretty common way of doing that. And those sensors are very robust, and the toothbrush won't harm them at all. So try to keep up with that. Stay ahead of that. So those are some of the questions I was prepared to answer. And so thank you to those that sent questions in advance. And I can see that quite a few questions have been coming in. So I'm going to try to get to a few of them. And let's see. So let me take a look through them. Yeah, there's a question about how durable our probes are. Are they going to hold up to erratic flows? Yeah, they're very durable. I'd recommend putting them in some sort of stilling well, like we've been talking about, either a PVC pipe attached to a rock on the bottom or a rock on the side of the stream. That'll help protect them and hold them in place. You definitely needs to be anchored so that it's not going to be washed away in the high flows. That's sometimes a challenge. So yeah, let's see. Yeah. Oh, just a point to clarify. There was a question: can a HOBO pressure transducer be used in place of a barometer. And yeah, this is for the barometric compensation of water level data. You have a couple of choices. You have really three choices. One is for the barometric data, you can deploy one of our water level loggers in the air, and that will record barometric pressure and with good accuracy. Another choice is we have weather stations that we sell that have a barometric pressure sensor option. Data from those stations can be used. And then you also have the option of using barometric pressure data from other weather stations in the area. But in that case, you need to format the data file from those other weather stations so that it's compatible with our barometric pressure import format. So, but that's all doable. You might have to adjust the data in a spreadsheet to get it into the right format. And so those are the three options for bringing in barometric pressure data. Yeah, here's a question. This is a little hard to answer, but I'm going to dive in anyways. What would be a recommended calibration field check frequency for conductivity and temp monitors? Things like the U24 are sealed, so is drift only factory determined and fixable, etc.? Okay, yeah. For the conductivity loggers, if you're deploying them in salt water, I would recommend getting out to them at least every month to clean off the fouling and take field calibration readings. Our software will allow you to take calibration readings at the beginning and end of each deployment segment, and it will do a kind of a linearly adjusted correction factor that will allow you to kind of compensate for fouling during that deployment. But you know, I think you really, in saltwater environments, you're probably going to need to be out there every month. And then during periods of high fouling, you might need to be out there every 2 weeks or maybe even every week. So really got to kind of judge it based on the amount of fouling that you're seeing. That's usually the biggest factor in drift. And the same thing applies to the dissolved oxygen loggers. Drift for our temperature loggers is not a big deal. So you really don't have to worry about measurement drift on those, except for maybe at the beginning of each season do a calibration check in the calibration bath like I was talking about, just to make sure that they're still accurate. So I'm running a little past my time here. Hopefully I haven't stretched your patience, but let me get to a couple more questions. Questions about getting the presentation. Yes, I will be following up with an email with recording, which you can access at any time. Let's see what else here. Got some product inputs. Thank you for the product inputs. Oh, here's a question that's come up a few times. It's turbidity. We don't have a turbidity logger at this time, but we do have users that are doing kind of crude turbidity measurements using our light logging loggers. So the pendants that have the temperature and the light sensors. And how they do that is they deploy one logger at a known depth in the water, and they might need a water level logger at that site as well to know how deep the water is, you know, at different times, so that they can factor that into their calculations. And then they have that light logger pointing straight up. That's usually the best way to do it. And then they have another light logger, pendant light logger, that's on shore measuring the sunshine during that time. And then you can come up with a ratio between the logger that's in the water versus the logger that's in the air, and that gives you a relative indication of the turbidity of the water at that time. It's not perfect, but it gives you an idea, and it's a fairly inexpensive way of doing that. So keep that in mind as well. Let's see. And for this case, I would recommend using the MX2200 series independent temp light loggers because they have the more accurate light sensor. Let's see. Question about deploying them or using the water level loggers at 4,000 meters. That's a good question. There is a point where the range, you typically actually gain range because the pressure is lower at the higher elevation. So yeah, you should be able to use them at the high elevations. But that's something to double check. I don't, I'd have to do the math on that to be sure. Oh, and here's a good suggestion on terms of measuring the turbidity. You can actually have two loggers that are both in the water with their sensors pointing up, and look at the ratio of the light between those two. So that way you don't have to worry as much about the monitoring the depth of the water. I like that suggestion. So thank you, Gareth, for that. That's a great suggestion. So I think I'm going to, the rest of these questions we're going to follow up because most of them are pretty specific. I'm going to refer you to a couple of resources. The first thing I want to just remind you about, and you've probably been there already, is we have a great website that has full product specifications and pricing. You know, at least if you're in the US, it will show the pricing. It's got webinars that you can download and view at your convenience. It's got tutorials on our software. It's got self-guided training, a lot of great information on our knowledge base and applications information, all sorts of information available on our website. So I definitely encourage you to go there and explore and learn using our website. The other thing is, if you have questions at any time, feel free to contact us at any time. We've got many of your countries, we have local distributors you can contact. So you can find out who your local distributor is on our website. We have application specialists here at Onset that you can reach by phone or by this email address that I show you, sales@onsetcomp.com. And we also have technical support available at this link. And so feel free to contact us if there's any way we can help at any time. So at this point, I just want to give a special thanks to Steve Hurley at the Massachusetts Division of Fisheries and Wildlife. He was a big help in pulling together this information and sharing his insights. So thanks so much to Steve. And then I want to thank all of you for attending today. Hopefully this has been useful information for you. And we really do appreciate your attention and your interest in our data loggers. So I wish you luck in your deployment. So thank you.